Welcome back, CIS 2531. Today we want to start diving into Chapter 11, which is talking about inheritance, so a continuation of our object-oriented programming chapter in Chapter 10. Hopefully you got through those videos in Chapter 10 where we talked about building a complex number. Today I'm going to start off with a object that's already been built, and I'm going to build something better based upon its definition. So you'll see here on the screen that I already have a class called account, so I'm building like a bank account object. And in this account I have a constructor, which the account holder has a name and a balance that's set to them. They're both private attributes. I have my print statement or my toString method. I have my get name, my get balance. I even have a deposit method and a withdraw method. The deposit will increase the balance by the past amount, while the withdraw method will decrease the balance by the past amount if and only if there's enough money in the account. So if the balance is greater than or equal to the amount that's passed in, it will deduct the amount from the balance. If it's too big, it won't do anything. It won't print anything or return anything. It probably should, but this is just a quick and simple example. What I want to make now is another class that is an account but more specific. So what I'm going to do is I'm going to create class checking account, which is an account. So I do have to provide the parentheses here and place something in there. I need to tell this class that it's going to be something a little bit different. It's going to be based on the definition of something else. So this class account is a class based on a account object. Okay, so it right now is going to get and be able to do everything an account can do, and then just fine-tune it. So it's essentially what inheritance is. It's starting with a superclass, a base class, and then creating a subclass where account is the superclass. So we have something to start with. A subclass is going to inherit or get all of the attributes and methods of the superclass. But what we can do is add more methods to it or tinker with it in any way that we want. So for instance, the very first thing that I might do in a subclass is again make a constructor that has the attributes of the superclass plus the new attributes of the subclass. Now I don't want to recreate the attributes of the superclass. That doesn't make a ton of sense. I want to try to eliminate as much code that I have to write as possible. But I am going to create a checking account as an account. You have this is relationship. A checking account is an account. So I'm going to come up with a constructor, def init, okay, init, okay, and in this I'm going to pass in the name and a balance, okay, because an account needs a name and a balance, so I might as well pass that into a checking account as well. And what I'm going to do is create an instance of account first, and then build more to my checking account. Now to do that, what I need to do is first call the superclass constructor. There's a couple different ways to do that. I can call that from the superclass itself. I can go .init and then call the method directly. And that's one way of doing it. I prefer using a super call. And so I say super, and then I pass in whatever I need. This is actually optional. I don't need this information at all. I just need to go super.init, and it will call the superclass's constructor. So the super is a direct line to the superclass. The .init is then calling the init method. This is an instance where I will have to call it explicitly so that I can tell it where to go. Now the superclass needs a name and a balance passed into it, so that's what I'm going to provide it with. I'm going to provide it with a name and a balance. Now I'm also going to make a checking account a little bit more specific, and I'm going to pass in a min balance as well, but that's not going to affect an account. That's going to be very specific to only a checking account. So a checking account has an attribute self.minBalance. That way, every checking account has a minimum balance that they have to maintain, and we cannot go under it, which is going to affect our withdraw method a little bit. So what I'm going to do is I'm going to start overriding some methods. Method overriding is a way to rewrite a method that already exists in the account class and give it more specific instructions. I can do that with my toString method, and I've already been doing that with my toString method this whole time. So if you remember in our toString method, every time I put it up in PyCharm, it shows this little up arrow and it overrides method and object. Why? Because it used to print the memory address location. Now it prints the account name and the balance as it works its way through. What I'd like it to do is do more of what it's going to do. So I'm going to go def str, and now this function already returns the name and the balance. What I'd like it to also return is the minimum balance. So it prints it in a very specific way, name, then on the next line, the balance. And so what I'd like it to do is also return that. So I'm going to go with this. Output equals super.str. Okay, so that's going to return what that returns. I'm going to go output plus equals, so I'm concatenating here, another f string for, we'll go /n, and we'll go min balance. And we'll put in our self.min balance. So we can already start to see how this is going to kind of shape up as we go. So let's actually make a couple objects of this real quick. So we'll go Control J, and we'll move our way through here. I'm going to create an account, acc1 equals an account, and we'll pass it in a name like Brandon, and we'll pass it in, you know, $1,200. Okay. I'm going to make a check acc1, and we'll make it a checking account. We'll pass in Tyler. We'll pass in 900 and a min balance of, say, 500. Now notice what happens when I say print acc1 versus print checking acc1. It's going to do it in two different ways. It's going to do it based upon how it's supposed to work. Now, let's see, type error, return non-string untype. Let's see, I must have made some mistake somewhere. Oh, I didn't put a return statement in here, so we're going to return output. Sorry. Let's go through and do that one more time. And you notice that it prints out Brandon $1,200, but for the next one, the checking account, it prints out a little bit more. So again, these objects know what type of information they are, and they're going to work with the methods that they have to work with. Account, or Brandon, is acc1. acc1 is an account. It's going to use the toString method from the account class. Whereas the checking acc1 is a checking account, so it's going to use the toString method from the account class. This method utilizes some of the methods from there. Now, had I not had this method at all, okay, I can still print checking account, but it only prints as if it's an account, okay? So this is an example of method overriding, but you always have the methods available to you that you want to work with. So for instance, if I wanted to take my checking account and make a deposit, I could do that. I can make a deposit of $500, and you see that when I print the checking account, now it's at $1,400. I could make a withdrawal from it of $500. And I could do that. Now it's at $400 because it was at $900. But remember, it had this minimum balance of $500, so I probably don't want it to go down to $400. I want it to maintain and be above that minimum balance. So you know what I'm going to do? Let's bring this back in. I'm going to override the withdraw method. We're going to pass in an amount. And we're just going to recode this withdraw method to do the way that I want it to do. I only want it to make withdrawals if and only if the balance stays above the $500, the minimum balance of the account. And it could be $500, maybe a different account has a minimum balance of $300, maybe another account has a minimum balance of $1,000. Each individual account can keep track of its own minimum balance, but I only want to make the withdrawal if my balance minus the withdrawal amount is greater than or equal to the minimum balance. So to get access to the balance, I'm going to go super, okay, not withdraw, I want to go super, okay, dot get balance, okay. Now remember, it's private, I don't have access to it here. I can't just go super underscore underscore balance or self underscore underscore balance. I have to call a method from the super class that is public, minus the amount. If that's greater than or equal to self.min balance, because that's in this class, then if that's true, then I can make the withdrawal. So I can go super.withdraw. So again, we don't have to put all this stuff in there. And I can withdraw the amount. Right? Otherwise, we might put an else in here, and we might print we overdraw in. So let's give this a shot and see what happens. So if I try to withdraw the $500 now from a $900 account, it's going to tell me that there are insufficient funds for the withdrawal. And I didn't print the accounts until the very end, so if I just delete those real quick, you won't see as much in the output. But you can see that it does say there was insufficient funds to withdraw. If I did try to withdraw, say, 200, it's going to do it just fine. It will make the withdrawal. You're not going to see anything. But if I printed the checking account, you'll see that I should have $700 in the account now, and it prints it out, and it says my balance is $700. My minimum balance is still $500. I can make deposits all I want. I can make withdrawals. I can change methods. I can add methods to this if I need it to do things a little bit differently. I can always add methods to this as I see fit. But all the inheritance relationship allows you to do is start with something generic and make something more specific, and that's sort of the big idea. So I started with an account that was able to do a few basic things, and it does them very well, and then I can create something more specific without having to recode my deposit method, my withdraw method, my toString method, or any other methods that I don't think I need to recode. I can just leave them as is. It will still work as I see fit, but I can change up anything that I need to as I work through this to fit for that specific type of object. And that's the power of object-oriented programming, specifically when it comes to inheritance, or at least one of the perks. The second perk is this idea of polymorphism. Polymorphism sounds like a complicated word and topic, but it really isn't. Polymorphism just means that something is taking on many forms. A polymorphic reaction is one in which we are calling a method from many different types of objects, but it happens to be the exact same method that we're calling from many different kinds of objects. It just so happens that these all objects share something in common, like the same superclass, the same parent. And since they all are derived from the same place, we can act upon them very similarly. So here's what I have. I have a class called person, and the person has a name and an age. The other methods are there just to kind of fill it in, but the method that I have here is called greeting. And what this person can do is say, hello, my name is name, and I'm blank years old today. Then I have a person or a student class who is a person. Again, it's built the same way we would. We built out as a person, and we created a grade for a student. So all students are in a grade. The greeting is a little bit different, though. It says, hello, my name is name, and I'm in the blank grade. And then I also have a class called employee, which is a person. So again, there's two layers or two separate inheritance relationships here. And an employee is a person with a name and an age, but it also has a title, okay? And the greeting greets very much like a person, and they will also say that they are of a given title, a doctor, a teacher, a firefighter, whatever it is. So there's some additional piece. So nothing really new here in terms of what we have, but we do have methods that are written in the superclass that are overridden in the subclass. The polymorphic reaction happens where you use it. So if I come down here, you're going to notice that I have three different people built. I have Jeff, who is an employee. Jeff is 32 and is a teacher. Abby, who is a person who's just 27, and Robert, who's a student who is in grade 12. What I do is I create a data structure, a list, a tuple, a dictionary, something, some sort of data structure that is a collection of these different persons. And yes, they are persons objects because Jeff as an employee is a person. Robert, who's a student, is a person. They all inherit from person. The polymorphic reaction happens right here. I loop through all of the favorite people lists that is person objects in it. And I ask each individual person to make their greeting. And when I do that, you're going to notice that each person makes their greeting in their own way. Hello, my name is Abby and I'm 27 years old. Abby was added to the list first, so it gives me a person greeting. Jeff is in the list next. Hello, my name is Jeff and I'm 32 years old. And I'm a teacher. So there's Jeff's greeting. And then finally, Robert was added as a student. Hello, my name is Robert, and I'm in the 12th grade. So a completely different greeting, not giving us his age at all, just giving us his grade as it works its way through. There is a polymorphic reaction happening. I am putting these objects together in a collection that's of similar data type. No, they're not exactly the same. We have a person, we have an employee, we have a student, but they are all person objects to begin with. And so we're able to go through each one of them individually and ask them all to do something that they all know how to do, and they all do it in their own way. This is the essence of polymorphism and how we can get things done very easily that would otherwise be very complex, because we would have to code 3 different instances and call each instance its own way, and we wouldn't be able to put them in a data collection, in a data set or a list or anything like that. And being able to do this gives us tons of freedom and the ability to move and process information very, very quickly. So hopefully that kind of helps with the inheritance structure. It is a short tutorial, but it is full of information. A subclass gets all the information, all the attributes and behaviors, all the attributes and methods from its superclass, and then we're able to also modify them, change them in any way, or add to them as we see fit. We cannot necessarily remove them, okay? But we can change how they do whatever it is they were doing in that superclass. So hopefully that helps out. If you have any questions, let me know. You'll be doing a graphics project for this particular assignment that will utilize a polymorphic reaction. I think you'll find it'll be kind of interesting and fairly simple to do. So let me know if you have any questions, and I'd be happy to help.